Versa SD-WAN training. And as Nitish mentioned, my name is Abhijit, and I'm going to be the instructor for this entire training. Now, before jumping into the content, I would just briefly introduce about myself. So, I've been delivering corporate trainings and consultancy for about 13 years now. And my key experience in the early days of my career has been in the domain of routing and switching. Later on, as soon as the SDN solutions started to become popular in the industry, I picked up that domain and I started learning the SDN solutions. And soon enough, I got introduced with SD-WAN as one of the solution. And I've been delivering trainings around SD-WAN solutions of Viptela or currently, which is known as Catalyst SD-WAN. And then Versa came up. So I started delivering trainings around that by learning about the solution. And I've delivered about more than 100 trainings just about SD-WAN and numerous other technologies is something that I'm pretty expert in. And that is exactly what my professional background is. And currently, I am acting as the CTO at PyNet Labs Private Limited. And I've been heading all the technical stuff that happens under the hood.
If you enjoyed the content of the video, don't forget to like and share the video and subscribe to our channel.
And personally, I belong from state of Maharashtra in India, but I've been living in Delhi for about 10 years now. So that's about my brief introduction. And in order to make this class even more interactive, I would also want you guys to introduce about yourself. You can just introduce about your name, then the organization that you work for, the role at the organization, right? Then the location you're joining in from, and the motive to join this class. Yeah, this will help me understand your expectations out of this training very well, as well as it will also allow you to know your peers in the training. So I would start one by one. First, I would like Ashok to introduce about yourself. Ashok, you can unmute and start introducing about yourself.
Hey everyone, my name is Ashok. I work for British Petroleum here in Houston, Texas.
Mm-hmm.
I'm part of a team called Site Engineering that manages BP's overall edge solutions,
Okay.
especially with SD-WAN.
Mm-hmm.
And I'm trying to learn more. I mean, I know I have a little bit of idea, but still I'm relying on Versa engineers for routing and switching and few other topics because
Mm-hmm.
these are pretty different to me. I mean, I'm from the Cisco world, and it's a little different to me. It's been
Mm-hmm.
challenging, so that's my motive to get this training.
Perfect.
That's
Thank you, Ashok. Then we have Gopinath with us. Gopinath, please introduce about yourself.
Yeah, hi everyone. Hi Abhijit. Hope my audio is clear, right?
Yeah, yeah, that's correct.
Okay, fine. Okay. So the organization where I'm tagged into HCL, and my role and responsibility is into I'm like an architect providing solution as well as the design and the implementation part of networking technologies, and the things are evolving. I started with the campus and all those legacy switches, now data centers, and I'm now landed in SD-WAN, where this is relevant for me because I'm new to this, to be very
Mm-hmm.
realistic, and
Mm-hmm.
I know the advantages and this thing, and from the legacy WAN
Mm-hmm.
topologies to this SD-WAN. So I understand the theoretical part. So
Mm-hmm.
I'm looking forward on this exercise so that I can be more relevant and apply this on the upcoming the org projects.
Yep,
And
makes sense.
yeah, and I'm based out of Chennai, India.
Okay,
So yeah, that's where my roles and motives are to land here.
amazing. Thanks, Gopinath, for the quick introduction. All right, and I guess we're pretty good with the introductions. So after the introductions, now we would get familiar about the content of this training. So for that, let me just wipe this out. And we're going to talk about the course outline. Now, discussing about the course outline, first we're going to talk about the, rather than saying fundamentals, I will say introduction to SDN, okay, software defined network. Then we're going to talk about fundamentals of SD-WAN. Now, whenever I'm talking about SD-WAN, we are referring to Versa's SD-WAN solution, right? Then after that, we're going to know about the components and architecture of Versa's SD-WAN solution. And then we will jump into the control plane and data plane operations using MPBGP, because Versa's SD-WAN solution consumes MPBGP as its overlay protocol. So it gets very crucial for us to understand how it really works. Now, all of this is kind of going to be theoretical discussions in our first couple of classes. Okay. And once we are done with them, then we will jump into the lab implementations. So when we get started with the lab, we first start with deploying Versa's head-end site. Now this is where we will have Versa director, right? We will have Versa analytics, and then we will also have Versa controller. And we will deploy these elements from scratch. After we deploy the controller site, then we're gonna deploy the branch sites using zero touch provisioning. Okay, that is something which we will implement. Post that, we're gonna establish the site to site communication using overlay, right? We will identify and implement the LAN to LAN communications between your branches, but in a secure way possible, or using the overlay. And then we will implement something called direct internet access, which is also called as DI. The DI capability will allow your branch sites to be able to communicate with the internet bound traffic, right? So your managers will start identifying the traffic's destination and then be able to encrypt the traffic record. So if the destination of the traffic is towards a remote site, then traffic will be encrypted to be sent into the tunnel, or encapsulated to be sent into the tunnel. But if the destination of the traffic is maybe internet, then the traffic will travel in the underlay. So this is what we're going to look at. And after we are done with this, then we're gonna talk about how you can implement hub and spoke topologies, right? In Versa's SD-WAN. Now, there are various flavors of topologies available. You have full mesh, which is by default used. Then you have hub and spoke, and then hub and spoke also has certain sub variations. You have spoke to hub only. You have spoke to spoke direct, right? You have spoke to spoke via hub. So we're gonna see and implement most of the topology types. After that, we're gonna spend time understanding the high availability in the Versa's SD-WAN. Right? We will understand how you can deploy your controllers and your managers in a high available fashion. And lastly, we're going to talk about the Versa SD-WAN policies. We're going to understand about the policy engine. We're going to look at how application aware routing policy works or application steering policies work, how security policy work, how QoS policies works and all of it. So all of this implementation is going to be like what? Theory plus lab. And then throughout the course, we also focused onto the monitoring and troubleshooting part. So there is no separate topic for monitoring and troubleshooting, whereas we will feed continuous knowledge and information about this topic as and when we progress throughout the course. So this is what the course outline is going to be about. And apart from the course outline, every participant will also be receiving the lab activity, I mean the lab access. So every participant will receive an isolated lab pod. And each pod will contain one, a Windows machine. So Windows jump host. And second one is going to be an UNG simulator. The Windows jump host is something which is connected out to the internet, and any user who is sitting over here can actually access that particular box. And then within that, from that Windows machine, you can access the EVNG. You cannot really access the EVNG simulator directly from your machine. You cannot do that. You can only do it by connecting to the jump host, and then from there you access the EVNG. So the details about the jump host credentials will be shared with you in a day or two, as and when we get started with the lab implementations. And then on the desktop of the Windows machine, you will see the credentials to access your EVNG simulator. And in that EVNG simulator, we are going to build our SD-WAN topology. Now in the topology, we will have various sites, right? You're going to have a site where the Versa director will be there, Versa analytics will be there, Versa controller will be there, right? And all of them are going to be connected together. Then the controller is going to be exposed out to a couple of transports like INET and MPLS. And then you will have multiple like WAN edges. So you might have like WAN edge number 1 and the LAN site. You will have like WAN edge number 2 and the LAN site. And you will have like WAN edge number 3 and the LAN site, something like that. And then you will have like dual transport connectivity on all the sites. So this is how usually the topology is something that's going to be created from scratch, right? We don't have a pre-deployed topology. We do everything from scratch so that you guys can learn how the process really needs to work. And that is about the course outline. So if you have any questions, please you can feel free to raise your hands, and then I will give you a chance to raise your question in the class. So, okay, Mohammed, you have a question.
Yep. So I was just wondering, are we also going to cover anything on Concerto?
We are not going to cover anything about Concerto, but I can talk about Concerto at brief because implementation is not really possible about Concerto, right? So
Okay,
by the end of the training, just give me a reminder to talk about Concerto and we will discuss about Concerto at brief.
got you. Thanks.
Yeah, awesome. All right. So since this is our day one, we'll keep it a little low, right? And we're gonna talk about the very first topic, which is gonna be introduction to software defined network, right? So talking about the SDN. Now, SDN pretty much stands for software defined networking, right? And SD-WAN solution is completely based on the SDN concepts. So SDN is kind of the architecture and SD-WAN is basically the product, which is based on the SDN. So in order to understand the SD-WAN solution, you also need to understand what SDN is all about. And to understand SDN, you need to better understand how traditional network really function. So when we talk about traditional networking, now networking has been very traditional for about 20, 30 years now. And we've been using a lot of networking devices, including routers, including switches, including firewalls, including load balancers, including IDS, including IPS, and whatnot. And there are multiple networking vendors who actually manufactures these appliances. So organizations like Cisco, organizations like Juniper, right? Then Palo Alto, and then Checkpoint and Sienna and whatnot, Huawei and all that. And every organization does provide one or the other way to control their device. For example, if we normally have a router, then what you do is you actually connect with that router by using an admin PC. Now, on that admin PC, you might be using Putty as your go-to application. And then over here, you would have a console cable. And then this is nothing but the console port. And then you create a connectivity, right? And then send the CLI commands to the device to be able to configure the device to behave as per your expectations. But this is not the only way how you can configure the device, right? You can also expose the device to the internet, and there can be someone acting as the remote user, still consuming like putty, but the remote connectivity is gained over like SSH or Telnet or nowadays even HTTP, and then he or she is able to control the configuration of the box. So in the previous, in the early days of networking, how it used to function is organizations would go and procure hardware from a single vendor. So some organization would go and procure hardware from Cisco. Some organization would go to Juniper. Some organization would go to some other organization, some other vendor, right? And once they procure the hardware, then they will also hunt for people or engineers who knows how to work on these hardwares. Because let's say that you are deploying Cisco's infrastructure in your production, then you will need network engineers who knows how to configure Cisco's devices and then hand over the procurement to them and they will deploy it for you. Similarly, if you have it for Juniper, you would hire Juniper people. If for Huawei, you would hire Huawei people and so on. Now, this is from an employer's perspective. But when you think about an employee's perspective, then the employee would also look forward for um, learning different ways of managing network devices. Then the employee would also look forward to learn more and more syntaxes so that he or she could manage or configure multiple devices and add value in the eyes of the organization. But this is not an easy job. As and when network engineers attempted to learn the different CLI module, they probably tend to forget the existing CLI syntaxes. And for that, you actually need to refer to documentations and all of that. Now that started becoming a problem. And this is where organizations introduced GUI access, right? The graphical user interface access, the GUI access. And with GUI access, for example, there is one of the very popular device called ASA firewall, right? Almost everyone knows that the ASA firewall can be connected to the management PC, and then you can use CLI or you can use a GUI to manage the box. If you want to use CLI, you would still use an application like Putty. But if you want GUI, you would use something called ASDM, Application Security Device Manager, which is a GUI tool to manage the ASA firewall. So without knowing any command about the ASA, you can still configure the entire firewall. And that somehow added a bit of extra comfort for network engineers to easily learn multiple vendors of devices and start utilizing them. Now, when you think about the configuration, let's say that you have configured a particular device and then it's working very well in the traditional environment. But if you look at some of its core functions, that what exactly does a device do when it comes to forwarding traffic? For example, let's say we have a very normal scenario that we have a router one. The router one has the switch and then it has few PCs. And then you have a LAN network called 192.168.1.0/24. And then you have router 2 has, right? And this is 192.168.2.0/2. And then you also have a connectivity, and this is 192.168.3.0/. And let's say that you have implemented static routing already. Now, if we say that I want to make communication between this PC to this PC, which probably might have like 1.1 and 2.1 as their IPs, then the traffic will first hit the default gateway. There will be like routing table lookup happening, then it will get resolved, and then the traffic will go to another destination, and this is where you're gonna have another routing table lookup, and then the traffic will finally land onto this device. Now, once it lands on this particular device, after that, the communication would work fine. But in order to provide this connectivity, a device is not really responsible to only being able to forward the traffic. The device has lots of other operations. For example, advertising the routes or installing the best route or calculating the best route and then figuring out the ARP address of the next hop, decrementing the TTL value every time the packet crosses a hop, right? Then looking at the CRC value or looking at the FCS value, you need to calculate the cyclic redundancy check to ensure the integrity of the data is perfect. And after doing all of these jobs only, your device will actually be able to forward the traffic, which means that it is pretty important for the device to also perform the other jobs. So all of these jobs that a device does, irrespective of whether it is a router or switch or firewall or so, all the devices do have three planes. So when it comes to user interaction, the user sits over here. And user interacts with the device with management plane of the device, which actually handles the CLI or GUI component of the box. Then second, it has control plane. Now that has CPU associated. So all the decisions, like all the best route calculation and everything that happens related to brain of the device happens in control plane. And then you have the third component, which is data plane, right? So the data plane is where all the line cards, the interfaces are associated. So once the control plane figures out what is the best route to reach out to a destination, it propagates that information to the control plane, and control plane stores something called forwarding information base, in which it stores the information that is decided. And then by using that information, it will be able to forward the traffic to the desired destination. So there is always this hierarchy that management plane can speak to control and control can speak to data. Management cannot communicate directly with data plane. The control cannot directly communicate with user, right? A user neither cannot really communicate with any of the other components except management plane. So this is how these three planes are very much important. Now, once you understand this, you know that how traditional network functions. Now we got to talk about what exactly are the limitations of traditional network, right? What are the limitations of it? Well, let's say I'll give you an example. For example, you have an ISP. Now that ISP provides connectivity to certain offices. Let's say this is your customer's office in Dubai, and there is this device, and then there is like LAN connectivity. And then you also happen to have this device where you happen to have LAN connectivity. And then you have the headquarter. Now that particular headquarter, or let's say this is in London, and then the headquarter has something called a server. And the server has like virtual machine number one, virtual machine number two, and virtual machine number three. And these are business virtual machines, which means they can be ERP solutions or CRM solution or certain other things. Now, the people who are sitting in Dubai and in London, they need to access this application, right? That is pretty important. So what you do is you put this file on the network. So maybe you will have redundant routers which are connected. Then you probably might also have a firewall or a redundant firewall so that the network doesn't break. Then you might have something called layer 3 switch, not one but multiple of them. And then you also might have layer 2 switch. And then finally connect the server to the switch. And let's say you also have taken care of the redundancy. So this is what the core of the network is. Then this is what the distribution of the network is, and rest of it is access. Now, to also achieve the same scenario, you will have to implement a lot of configuration change, right? Maybe you will have to configure BGP, you will have to configure OSPF, you will have to configure, or rather, I'll say reconfigure access control list, the VPN configuration, the SSL configuration, the VLAN configuration, the VTP configuration, the spanning tree protocol configuration, the inter VLAN routing, and blah, 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 blah. So there's so many of these configuration elements that goes on almost every device that you have, and you will have to do it one by one. And this is where limitations start coming up. So when you look at the limitations, A, you do router by router configuration. Right? B, the configuration is secure. While it is traveling, it is not being um, snooped, or it is not being sneaked, that what exactly are the contents of this particular file. Right? You have to do that. You can do that. And third, you can say that because the configuration is actually being done by a human, so it is manual configuration, which is also error prone, because it is very easy to understand that the humans, when they try to push some config to the device, they might push it in a wrong way. So these are some of the limitations which you have. And you can achieve all of these limitations by implementing SDN. Because what happens in the traditional way is, because the configurations are done on every single device again and again, the human who is responsible of doing it is also tired of doing the same config again and again and again, right? Then it is very error prone that the user might push wrong configuration or store wrong information into the configuration database or so. Yes, Mohammed, you have a question.
Yeah, so why is configuration being secure is a limitation?
So configure, oh, okay, wait a minute. Shouldn't be like that. Configuration isn't secure, is what I meant.
Okay.
So configuration isn't secure. Now, when we look at such limitations, then in that case, uh, Cisco also, you can say, released one of the report that almost 70 to 80% of their customers were still doing manual configuration. And since they are doing manual configuration, about 70% of the tag tickets that they receive from these customers, they are just because of misconfigurations. So you can say the configuration is not secure in a way that it is prone to errors. Anyone can actually, or I have already written that down below, right? So we're good. Yeah. Anyone can end up pushing wrong configuration or misconfiguration on the device. And that particular configuration is going to cause a problem. So your site might go down, or your reachability might go down, your application may become unreachable or unresponsive. All of these issues can come up, right? And you need to address them. Now, in the traditional way, what happens is exactly that: the management plane, the control plane, and the data plane is actually located on every single device. That's why the configuration needs to be done one by one by one on every device, because the management plane is separate, the control plane is separate for each single device. Think of a use case that the same organization now has a requirement that they need to introduce three new applications, like application number 4, application number 5, and application number 6. These are new business applications. And then the reachability of these new applications must be provisioned. Now think that what exactly would be the configuration which you will push on the devices. And it's going to be a lot, right? You will have to modify your BGP, you'll have to modify your internal OSPF, you'll have to modify your VLANs, have to modify your routing, your access control list, your VPN credential, everything, just to provide or just to provision the reachability of the new applications. And if it is done in business hours, then it is going to impact the network. So usually such kind of change is actually done in um, non-business hours, right? So you can take a maintenance window and then start doing all that change. And this is all traditional way of managing network. Now, where SDN comes into picture is that it changes the approach of how the planes are stored onto the device. So when you look at the SDN approach, in that you have something called the admin machine, and the admin is actually communicating called controller. The controller is connected to ISP, and ISP is connected to infra. And this communication is divided into two pieces. So whenever there is any communication that happens between admin and the controller, it is called as northbound communication. And whenever there is any communication between controller to the infra, then this is southbound communication. So what happens in SDN is the infrastructure devices. So maybe you have routers, switches, firewalls, whatever, all of that. All these devices, right, will only return, or the infra devices will only retain data plane capabilities. And that is the biggest advantage of it. And then the controller will actually have the control plane and management plane capabilities. This is what it changes. When you actually implement SDN, then your infrastructure device will give away the control plane and management plane capabilities, and then they will only have local data plane. Now, when you have local data plane, it means that the device now can focus entirely or solely to forward the traffic, right? The device or the router is not really responsible for calculating the best path, right? Or sending the IPsec key negotiation. Nothing is really uh, stopping your manage from only focusing on the data plane capabilities. Now, since the control plane and management plane is centralized, so now admin will kind of make an intent. The admin might wish to communicate with the controller, hey controller, I want to do some config in my environment. Controller says, okay, which devices do you want to do it on? I will say I want to do it on Vanish 1, Vanish 2, Vanish 3. Controller says, okay, what config? I will say OSPF. Controller says, okay, but what parameters? I'll say process ID 1, area ID this, the neighbor ID is this, and so on. And then once you do that, you actually commit that change, and the change will actually be sent to the infrastructure device. Now, this can be a single device configuration, or this can be a multiple device configuration. It varies depending on the requirements or depending on the scenario, right? But because it takes away the management plane and control plane capabilities, whatever configuration that you as an admin is trying to push onto the network device, the configuration by the set of controllers gets validated. Whether the configuration is syntactically correct, functionally correct, and programmatically correct or not. If it is correct, then only the configuration is accepted. Otherwise, the configuration is going to be rejected, right? And that particular process conceptually optimizes that how traditionally network devices were being managed and how in today's world network devices are managed, right? So that is what the SDN architecture is all about. The SDN architecture's takeaway is to reduce the complexities that are present on each single device and centralize that particular complex calculations in a centralized controller, and then just relay the information, the decision to the end device. And that should pretty much do everything which it requires. Make sense? So in our case, the controllers now, the SD-WAN solution, the ACI solution, the SD access, the NSO, everything is based on the same architecture. It is just the infra devices which changes. Like if you want data center nexus devices to be added and to be managed, then the devices will no longer be managed devices. If you want enterprise devices like routers and switches to be managed, then the SD-WAN is not the solution. You should go for SD access. If you want data center nexus switches to be managed, you should go for ACI as your solution. And if you want WAN edge devices to be managed, then you come to SD-WAN as one of the solution, which comes under the hood of SDN, right? So in our SD-WAN scenario, the control plane is going to be controlled by the Versa controller. The management plane is going to be controlled by the analytics plane. I mean, sorry, the management plane will be controlled by the Versa manager, and Versa director, I would say. And then there is additional plane called analytics, which actually stores the historical data, and based on that, it can allow you to create reports and audits and things like that. So that is what SDN is all about. So when we actually learn SD-WAN solution, our main goal is to understand how the optimization of the configuration processes have been done into the SD-WAN solution. And SD-WAN solution cannot manage any type of device. It can only manage certain type of device, right? So I'm also going to show you a list of all the managers that can also be managed over there. So this is what SDN is all about. Now, if you have any questions, you can raise your hands. Perfect. So when we move forward to learn about the SD-WAN solution, we will understand how each component of Versa's SD-WAN solution really works, talking about the director, the controller, the analytics and all that. And then we will get an understanding of how the control plane and data plane operation work, because there are various benefits that SD-WAN as a solution brings on the table. It allows you to onboard your devices automatically. It allows your managers to automatically form the IPsec tunnels. It allows your route advertisement to be done automatically. It allows your overlay tunnels to be formed automatically. But how does it really do that automatically? That is something which is going to be our motive moving forward. But yeah, to understand SDN is pretty crucial. That allows you to have this proper understanding that when you talk about SDN solution, then it can be any solution which centralizes or which decouples the control plane and management plane capability from a local device. And then you can centralize that, right? And it can manage all the data plane nodes from a central point of touch. And pretty good. Okay, I see no questions. So on our day one, that is something which we wanted to talk about. I'll keep the session a bit short. And we talked about the introductions, we talked about the components of the SDN, we talked about how SDN generally functions. And then we took an understanding towards what kind of SDN solution is going to provide automation for your managed devices, right? And that's going to be SD-WAN, of course. So moving forward, we got to understand what each component of the Versa's SD-WAN solution does, right? That what is the role of director, what is the role of analytics, what is the role of the controller, and how really we can deploy them, and what all are the deployment options that we have. That is something which we're going to look at. But yeah, for today, we're pretty good. And we're going to talk about the fundamentals of SD-WAN. Now, of course, whenever I'm saying SD-WAN, I am speaking about Versa's SD-WAN, right? And in this, we're gonna discuss about what exactly are the benefits of Versa's SD-WAN solution, or how in general the SD-WAN solution allows you to kind of achieve automation in its WAN management. So there are a few benefits that you should talk about when thinking about an SD-WAN solution. Yesterday, we saw that the SD-WAN solution is based on the SDN architecture, which means that the SDN architecture looks something like this, right? Where you have the admin, then there is some controller, and then down below you have maybe connectivity of the ISP, and then down below the infrastructure which the controller would manage, the SDN controller would manage, right? And you break this particular communication into two pieces. So this is gonna be your northbound, and this is gonna be your southbound. So in that, if you now compare the SD-WAN, I mean Versa's SD-WAN architecture, then you still have an admin machine, but that admin machine is connected to something we call as head end. And the head end is collection of few directors. Okay, so the first um, collection of few controllers. So the first controller is gonna be the Versa director. The second controller is Versa analytics, and the third controller is Versa controller itself. And then you can connect the controllers to the ISP, irrespective of whether that's a public ISP or private circuit-based ISP or cellular network. And then you have connectivity to different sites. So this may be your WAN is number one. Then this may be your WAN is number two. And this may be your WAN is number three. And maybe you have a site where you have WAN 4 and WAN 5 together. Something like this. So all of these are nothing but your branches. Whereas this is, let's say, Delhi, this is Bangalore, there is Pune, and maybe this is Hyderabad. So you would definitely want the connectivity between these sites. Now, in a traditional environment, each of this particular site will, of course, have some LAN segments, right? You will have a LAN segment over here, like LAN 1. You would have a LAN segment over here, like LAN 2. Then maybe over here, LAN 3. And then you would have LAN 4. Now, if I say that LAN 1 wants to communicate to LAN 2, then you will have to make sure that the communication across Delhi to Bangalore is secure. Now, this is where one of the major benefit comes up. When you deploy your SD-WAN site, then when you look at some of the benefits, number one is automation for onboarding new sites using ZTP, which is called as zero touch provisioning. This is one of the first benefit that SD-WAN introduces. And what this benefit is all about is whenever there is any new site which needs to be deployed in your fabric, then nothing really needs to be configured on that device. Okay. With the help of zero touch provisioning, you would be able to onboard your Vantage by just barely connecting it to the internet, or by exposing its internet connectivity to the service provider, or by running a Python script, or by using a URL onto the device. There are, however, three popular methods. One is global ZTP, then the other one is script based ZTP, and then the other one is URL based ZTP. So all these three methods are something which we're going to dive deeper into in order to understand how the zero touch provisioning works. But for now, to understand it as a benefit, I want you to know that onboarding of the new Vantage is completely automated into your SD-WAN's solution, right? So that's very much appreciated by the industry. I guess we have someone who has a question, and the name is Puneet. Please go ahead.
Yeah, Abhijit, like in Viptela, we need to do some vanilla configuration in edge devices or controller.
Mhm.
So we don't need to do anything in
No, we
Versa.
need to. We need to do it, but you don't have to really access the CLI and then maybe configure something. All of that basic configuration is deployed with the help of a script.
Okay.
Yeah, and
So
we're gonna
manually, we
learn
don't need to do anything. Everything will be done by
manually.
the
No,
script.
that's
Okay.
correct. I mean, you manually need to run a script and then provide the basic configuration as an argument to the script, but that's fairly easy.
Okay.
Yeah.
Thank you.
Then after the advantages are onboarded, there comes your second benefit. Now, in traditional environment, whenever, for example, this new site is deployed, right, as it has become part of your fabric, what you will do is you will configure this site to establish overlay tunnels with the other devices. Make sense? So that these, like for example, IPsec tunnels will be established. Now, where does these IPsec tunnels comes from? Why do we really require that? I'll give you a scenario that when you look at a service provider environment, that dummy service provider environment. Usually what happens is if you have a site, for example, this is your site number 1, and then this is your site number 2, right? And then in between, this is your ISP fabric. What you're going to have is you're going to have the CPE device, customer premises edge, and the CPE device on the other side. And then you will connect the CPE device to maybe PE1, provider edge 1, and then on the other side, PE number 2. And then in between, you will have lots of P devices, right? And then down below also for redundant path, you might have it. And then connect them together. Then maybe I will have it this way or this way, right? This is your ISP fabric. So the location that I will say that this is your Bangalore location and this is your Delhi location. Now, in that case, when you're going to provide the connectivity of CPU with CP1 with P1 and CP2 with P2, that is where the connections, I mean, that is where the backend traffic starts traveling into public transport. So if you have a LAN segment, like this is where you have router 11 and then maybe router number 12. And on this side, you might have router number 21 and then router number 22. If I say that the prefixes which you have over here is like 192.168.11.0 and 192.168.12.0, and on the other side we have like 192.168.21.0 and 192.168.22.0. When you have that, the 11.0 and 20.0, both of them needs to be advertised out to the CP and then to the other devices. And these network also should be advertised over here. So what you usually do is you actually establish an eBGP neighborship in a normal service provider environment, and you advertise these routes as BGP routes to there. And then the provider edge will receive the BGP routes and then have maybe iBGP neighborship, right? Over maybe OSPF or something like that, and then advertise the 11.0 and 12.0 on the other side. And similarly, these 21.0 and all over the iBGP will be given to PUI, and then it will give it over. This is how the information is exactly exchanged. And once done, whenever we build then manual IPsec tunnels, right, between the CPE device and the CPE device on the other end. And when we have that, then whenever the traffic goes from 11 to 21, it will travel encapsulated in the tunnel and get delivered. Whenever the traffic goes from 12, it will be encapsulated and go down to the rest. And if the traffic is intended toward the internet, right, maybe 8.8.8.8, then there is no encapsulation. Then there is the traffic which is basically sent using the underlay. But if the communication is happening between the branch, then it is done in the tunnel, which we call as overlay. And you pay the rental to the service provider because it is providing you common connectivity from one point to the other. Now your tunnel is established in this fashion, right? But that tunnel very much depends on the physical connectivity of your ISP. If this link goes down and this link goes down, the tunnel is gone. Or if rather any other connectivity goes down and you lose the reachability from the public IP address of this end to the public IP address of this end, if there is no reachability, then in that case, your reachability between the branches have gone down. So ISPs really make sure that by using alternate paths or whatever means, the reachability from one point to the other point is always up and running, 99.9% of the SLA. And once it is running, then the customers can actually form their overlay tunnels on top of. But think then that if you have 500 sites, then this device will need to create tunnels with every other vantage that's there. And that is where the pain starts, right? So it takes more and more time. The larger the site is, the more time it's going to take to form these tunnels, because configuration of overlay tunnels is critical. It is not an easy piece, right? You need to make sure that the phase one IPsec phase one parameters matches on both ends. You need to make sure that the tunnel is up and running and active whenever the traffic is forwarded. There are lots of processes involved, right, in production. So the second benefit, the most loved benefit, that formation of overlay tunnels between the branches is also automated, right? This is the second benefit that the SD-WAN brings you on the table. So whenever the new vantage is identified as part of the fabric, then that particular vantage will be able to form tunnel with the other branches automatically. So from here to here, there is going to be a tunnel. From here to here, there's going to be a tunnel. From here to here, from here to here. All of these tunnels will automatically be built up. You don't really need to make sure that manual configuration in place or something like that. Everything is done automatically. Then after the tunnels are up, like I said, once the tunnel is up, you need to make sure that these routes are advertised properly and these routes are advertised properly. So that particular route advertisement, right? Your LAN routes are also automatically exchanged between the branches, right? All your LAN routes are going to be automatically exchanged between the branches. So no need for that. No need to do the manual redistribution. No need to configure the routing protocols to advertise. Nothing really needs to be done. Everything is automated. And then on top of that, it provides you, or the solution provides you the central control for the entire fabric. Okay. Which means that you can actually deploy any type of configuration that you wish with the help of this central control. Because you are sitting over here, okay, then you are only going to log in into the director and you say that, hey, I want to deploy maybe OSPF configuration on my vantage number 1 and on my vantage number 2. So the director will say, okay, give me what config you want. The director says, okay, this. The director says, okay, I got you. And then the director informs the controller to actually push the configuration change on both the device. And both of these devices will. The admin will not be required to do any configuration locally on the device at all, which was earlier the practice, right? So because it provides you, because all of these particular advantages are administratively controlled by the head end, that's why you can actually just communicate to the head end and pass your intent, and then the device will actually be, the necessary advantages will actually be configured automatically, right? That's why I say the solution provides you central control for the entire fabric. And since the controller, the head end, provides you with real time and historical insights about how your fabric has been performing. So if there has been any bandwidth utilization, if there has been any SLA violation, if there has been a case where the vantage did restart, if there has been a case where the bandwidth over subscription is about to happen, all of these data is actually provided to you in the director as well as in the analytics. Depends what type of data that is. But yeah, when you have such sort of data with you, then it allows you to implement something which is called as proactive troubleshooting instead of doing reactive trouble. So there is this term called proactive troubleshooting, which is getting very popular in the industry. What it means really is, think for a moment that uh, there has been a bandwidth over subscription on one of your site, and due to that, the important traffic is actually being dropped. Now, as soon as this issue comes up, someone will raise a ticket and someone will look into that issue and then spend time analyzing what exactly is the problem. But instead of that, because in the SD-WAN solution, the controllers already know what kind of or what amount of traffic is being sent from what some branch to some branch, and what kind of utilization the solution is exactly witnessing. It can provide you insights and suggestions that will lead you to take some decisions for doing some manipulation or doing some configuration change. For example, you can put up a policy that if you see a peak in the bandwidth consumption, and then the controller kind of notifies you via maybe an email or via a log or via an alarm or so, and you get notified that there is you can say unprecedented bandwidth utilization which is being witnessed. Would you like to take a look? And before the network actually goes down, you will be able to make a decision to probably push some policy and divert that traffic to some other transport, or limit that traffic, put a QoS policer there, and blah blah blah. You can take all these decisions. Why? because you have good insights about your network, because the controllers are keeping an eye on how your fabric is performing, right? So these benefits kind of lures the customer, lures the organizations to shift their way of how managed devices are being managed. And remember, the SD-WAN solution is only concerned about managing the WAN edge devices. It does not really bother about what your LAN devices have been configured with, or how does your LAN devices are currently functioning. No, the SD-WAN solution's only concern is to be able to manage and automate the workflow for the WAN edge devices, right? And that is exactly what we're going to jump into. So this is the fundamental idea of what SD-WAN solution is all about. Any questions? Please raise your hands. Ashok.
Yeah, can you give me an example of this controller intimating or informing about some issue or port saturation?
Yeah, for example, when you log into the director, you actually can see what the bandwidth utilization of your WAN transports are. And then it is directly going to give you a graph, right? Which means that it is tracking that, for example, if you have configured that interface to be having maybe 100 Mbps of speed and the bandwidth, then in that case, if the bandwidth is going 70% or 75%, where you can set a threshold, then you can actually configure a policy that as soon as the traffic hits 70% threshold, then divert that traffic by using my second WAN interface, or maybe to the second transport that I'm connected to.
You mean to say SLA monitor?
Kind of, yeah. There is the policy is called as application steering or traffic steering based on application or based on IP, which monitors the SLA. And then based on that, it also performs configuration change on the device when the situation arises.
Okay.
Yeah. Someone in the chat have highlighted that once our CP is onboarded, if director is down, will it impact? No, it will not. It will not impact the data traffic, because the director only requires reachability to monitor and to push new configuration. So while your director is down, you will not really be able to push any new configuration. You will not be able to add new managers or so, but your existing fabric will function as it is. Yeah. And while that director is down, if the new routing updates comes up, then in that particular case, the controller is going to take care of forwarding the same, right? So that also doesn't cause any problem. Director is basically just providing you the granular control to manage your fabric. Nothing else. Yes, Puneet.
Suppose we will lose the reachability to controller, then what will happen?
If reachability to the controller goes down, then your direct tunnels between the managers will maintain their connectivity, and they will continue to forward the traffic. But then new route exchange and new configuration changes again will not be pushed at all.
Okay.
Yeah. Awesome. Okay, Ankit.
Yeah, so V analytics also can predict the future bandwidth utilization. This has that capability in Versa as well.
Yeah, you can set up rules like if the bandwidth is exactly doubling down its utilization every 5 minutes, every 20 minutes, then you will see that in the graph, right?
Okay.
However, it's not going to deploy any configuration change just by looking at that particular graph. You will have to do that, but you can set up alarms and monitoring in a way that it notifies you to take the action before it crosses the threshold.
Okay.
Yeah, perfect. Gopinath.
Yeah, so my question is like, I'm not sure whether we'll be covering it.
Go
So
ahead.
what is the minimum controller requirement? Is it one or a cluster, and those things will be covering?
What is the
later,
meaning of
or
what? Controller?
like, will it be like a single controller or it will be like a cluster? So
No, you
they
can
will
deploy
be
it in standalone mode, or you can deploy it in a high availability mode or a cluster mode.
okay.
In
So it
production
will be covering
environment, of course, you're gonna deploy it in a cluster mode. But in a lab environment, we're going to deploy it in standalone mode. And I'm gonna teach you how you can deploy it both in standalone and in cluster mode.
And also the tenant based kind of a stuff. Right?
Yeah, of course. Yeah, every configuration done in Versa's SD-WAN is tenant-based configuration.
Okay,
Yeah,
fine. Okay, thank you.
awesome. All right, now, okay, Ankit, go ahead.
So, how many V directors we can have in the network? Like it depends
We're going to
upon
talk
the.
about all of that in the control plane and data plane operations.
Okay, got it.
Yeah,
Okay.
that's fine.
So I have a few more questions. Okay, no problem.
Go ahead.
We'll
Go
wait
ahead.
for
Go
that.
ahead. No, no, go
Yeah.
ahead with your question,
Like
please.
if we do have the clusters of V directors,
Mhm.
is like every V director is in active mode or in it's something else. It's only one V director will be
I
working
guess
at a
this
time.
is something which we're going to discuss in this section when high availability topic will come up.
Okay, got it.
Yeah,
Yeah, thank you.
perfect. In case the controller is down, so any, like I mentioned, Deepika, there won't be any impact on your data plane traffic. Your branches will continue to function normally. It's just that new changes will not be accepted at all until the controller is back. Awesome. So now we're gonna understand the role, I mean, how the underlay and overlay networks really function, and then what exactly each controller is gonna do. We have basically, when you look at the components of Versa SD-WAN, then number one, you have Versa Director, which handles the management plane operation. Second, you have Versa Controller, which handles the control plane operation. Third, you have Versa Analytics, and fourth, you have Versa Edge Device, which is the data plane. Like I mentioned, the Versa Director is gonna be your go-to controller. This is the controller which will provide you the GUI access, and you're gonna log in into the director every now and then. After that, the controller and the analytics are added as the infrastructure device of the fabric. So whenever we're gonna set up, we will have in today's class, we're actually gonna set up the controller head end. And what we're gonna do is we will do the basic setup to actually access the GUI of it. So when we set up the head end, we are gonna build up a topology like this, where we're gonna have the Versa director, then we're gonna have the Versa analytics, and then we have the Versa controller. And the controller is going to be connected to a couple of routers, which are normal iOS routers, but they're going to be treated as your ISP transports. And then over here, you will have a bridged interface. And over here, you will have a layer 3 switch, normal layer 3 switch, and then provide connectivity in this fashion. So there are two types of connectivities. One is you have northbound connectivity, and the second one is you have southbound connectivity. The northbound connectivity is used for management purpose, and the southbound connectivity is used for communication with your WAN edges. Okay, so The interfaces that we will have on this is going to be Ethernet 0 and Ethernet 1. Then over here, Ethernet 0 and Ethernet 1. On this side, it will be Ethernet 0. And this is going to be VNI 0/0, right? Although I will explain you what is the VNI 0/0 means. But for now, just for theoretical understanding, I will keep it as Ethernet 1. And then Ethernet 2 will come there and Ethernet 3 will come there. But that's none of our concern right now. So what we're gonna do is for northbound interface, we're gonna use a subnet called 10.255.1.0/24. And then for southbound, we're gonna use 10.10.10.11. I would say, yeah, 10.10.10.0 rather. And then the director will be configured with .111. The analytics will be configured with .112, and the controller will be configured with .113, which means that its Ethernet 0 will be configured with 10.255.1.11, then Ethernet 1 will be configured with 10.10.10.111. Similarly, this will be with 112, and this will also be with 112 from the specific subnet. After we provide the basic connectivity, then in order to set up, we need to register our analytics node into the director. So this is where we create something called Versa Analytics Node Cluster, right? And in that, we're going to add the analytics as part of the director. Why do we need to do that? Well, analytics do provide a separate GUI interface, which means that my Windows jump host is connected to the same cloud interface. Now, if I sit onto my Windows and if I say HTTP and the northbound IP address of my director, like 10.255 or 1.110, then it will open up, sorry, 111. It will open up the GUI of my director. And if I change that to HTTP ://10.255.1.112, then it is going to provide me the GUI of my analytics, because analytics stores the historical data of how your entire transport has been functioning. And based on that, it will suggest you what kind of changes you can do. So when you register your analytics node into the director, you will no longer have to access the analytics separately, because in the director itself, you will be able to access the GUI of analytics. That's why it is necessary for us to register our analytics to the director. And then it is also important for us to register the controller in the director. Make sense? Why do we need to do that? Because whenever, let's say, there is going to be like managed connectivity, and this admin machine decides that on this vantage it needs to deploy, or we need to deploy OSPF. So the PC is going to log in into the GUI of director, and it's going to instruct that, okay, this is the OSPF config which I want to do. Director is not directly going to communicate with vantage and send that config. No. Okay. The PC will tell the configuration to the director, and the director will inform to the controller that, hey, controller, can you please send this configuration change on the vantage? And the controller will do that. That, hey, vantage, here is the new configuration that you're going to function with. And please accept that and give me an acknowledgement. And done. This is how configuration changes are pushed. So that's why Versa controller handles the control plane. The director only handles the management plane. Okay. But if you don't register the controller node also in the director will not know to whom to forward the configuration request. And that's why controller and analytics both needs to be added into the director. And once you add both of these components into the director, then your head end is deployed. This is what the process of setting up the head end is. Any questions? Please go ahead. I guess meanwhile, in Deepika did put a question in the chat that in case the controller is down, any impact on the branch segment, which I addressed that there won't be any impact. And she also says that, so if both are down in case, so how will traffic is shift? Well, if the branch is also down, then there is no traffic flow at all. That's why you implement high availability, that having multiple managers. If the site is too important for you and you cannot really afford to have that site going down, then you would deploy high availability in that site. Either have dual transport connectivity, or you have dual vantage setup, or multiple vantage setup over there, or both. And that's how you can make sure that the branch is always available. Okay, Mohammed, you have a question?
Yeah, so in this topology, why are we using both the connection methods like bridge as well as the L3 switch?
The bridge is going to provide you connectivity between the Windows PC that you're going to have. So each lab environment will be provided with one Windows jump host, right? That's going to be your management PC,
Got you.
which is actually connected to the internet from our data center. And then you are sitting somewhere, let's say over here in the world. And then you will be provided a portal access, like for example, http blah blah blah.com, that will open up the lab login portal. And then you will also be provided with the credentials. When you put those credentials, you will be connected. You will be able to access the Windows machine. From that Windows machine, you access the second machine, which is going to be EVNG, inside which the topology is going to be created. Now, since the director is going to be part of that topology, from this Windows machine, you need to access the GUI of the Versa director node. It's not locally installed in Windows, right? So that's why this bridge connectivity has to be there, so that communication between Windows and Eve nodes can be done. And that communication is done over a fixed subnet called 10.255.1.0, where dot 51 will be fixed over there. And then you provide dot 111 to your director, dot 112 to the analytics, dot 113 to the controller. Make sense?
Yep. Thanks.
And then we use the southbound via which the director will be able to, or the analytics will be able to communicate with your vantage devices. So whenever we talk about taking or doing the communication from Windows with the controllers, this is northbound. And when we talk about the controllers communicating with the devices, that is done over southbound. Cool?
Yep.
Awesome.
Abhijit, Gopi here.
Yes.
So this /24 for northbound,
Mhm.
is it only to play with these three peripherals, VA, VC,
Yes.
we need
You don't need out
any?
of band management connectivity for Vanages. You don't need that.
Okay, and if I'm designing it, the southbound range
Yes.
should accommodate all the edges that we plan to
Yeah,
deploy. So it
that's
will be
correct.
a bigger range if it is something bigger, right?
That's correct. Yeah.
Okay, okay. And this cluster of hidden with VA, VC, can it be like a cloud based
It can.
infrastructure?
You can deploy these controllers either on premises or on cloud.
Okay. And can it be in a hybrid mode? Some directors can be in cloud and controllers.
You can, yeah. As far as the reachability is there won't be any problem at all.
There is no latency like restriction like
No,
we have
no.
it.
There is no utilization like every minute there is GBs of data which are being exchanged. It's not the case, right? So there's no latency requirement as such. The only thing is reachability should be there. Yeah,
That's
this
a
is
very
not
big
latency sensitive data which it is exchanging. It's barely TCP based data. So it's completely fine.
okay. Thank you.
Yep.
Abhijit, can we call northbound as our traditional autoband management, or is there any difference between the
It
two?
is out of band management.
That is all right. It is
Yeah.
as simple as providing autoband. Okay.
Yeah. Of course, yes. Okay. I think we're pretty good. So now what we're going to do is I'm going to show you how the lab access will be provided to you. And I'm going to build this topology. And I'm simply going to set up the basic IP addressing on these controllers. Okay. Once the basic IP addressing is done, then we are going to, you can say, access the director's GUI. And we will just take an overview of the director's GUI, and we will do the basic IP configuration on the other components. Once it is done, then we're pretty good. Yeah, that is what the motive for today's session is gonna be. So you can see that once I log in into the Windows machine, after that, you are gonna see a sticky note on the desktop, and that sticky note will contain some detail, which would say that to access the EVNG GUI, open Firefox with below details. And the details would be about a URL, a username, and a password, which are going to contain the details about the EVNG. So since I already know about the details of my EVNG, I'm going to start my web browser, and then I will access my EVNG on an address, which is http 192.168.3.183. And these details are unique for everyone. So you're not expected to access the EVNG at the address at which I am accessing it, okay? Every participant of this training will have a unique EVNG and unique Windows machine. So look at the sticky note when the labs will be provided to you by tomorrow. And I'm going to log in into the EVNG by using the credentials. And then I will land up onto a page like this. This is the management interface of your EVNG. On the left side, these are like list of all the labs I am working on currently. In your case, it is going to be empty because you're going to create a new lab from scratch. So how do you do that? Well, you simply click on a button which is over here in the menu item. The first button itself is about adding a new lab. I'm going to click on that and I'm going to name it as instructor led online weekdays 3007 Versa SD-WAN. And then I'm going to click on the save button. As soon as I click on the save button, the topology page will open up for me. There you see. And this is where we're going to create our topology. It is blank right now. None of the nodes are added. Nothing is there. On the left side, you have a menu of EVNG, right? If you use logout option, you will completely be logged out of the EVNG. And then if you log in again, you will land on the same page where you left from. Then the second last option is to close the lab. When you click on the close lab, you will log out. I mean, you will be out on the management page. And here you can see the topology, ILO weekdays 3007 Versa SD-WAN. I can click on that and then click on open and the topology will open up. This is where we're going to add all the nodes. So in order to add the devices in the topology, you can click anywhere, right? Like this, right click anywhere and a small dialog box will pop up, which says add a node, add a network, add a picture, add a custom shape, add a text. What do you want to do? So I'm going to click on add a node. When I click on add a node, there I will say search for Versa and then you will find it. Some of the devices are in gray color, some of them are in blue color. So the devices which are in blue color, they are installed inside your EVNG, and the ones which are in gray color, they are not installed in your EVNG, right? So you will have the devices which are required for the Versa SD-WAN training already installed in your EVNG. So I'm gonna select the Versa director. When I click on Versa director, it gives you the modification page. Now this is where you can change the name of the appliance, but I'm gonna keep it as it is. Then it tells you that it requires 2 CPU and 8 GB RAM for booting up, right? And then it also comes with 2 interfaces. So you don't need to change anything. The only thing is you're gonna scroll down and change the console option from VNC to RDP. Okay, sorry, from VNC to Telnet, not RDP. So that you can take the putty console access of your director, nothing else. So do that change and then save it. And you can see the device up. If you think you have mistakenly placed a device, you want to delete that, you can simply hover to that. Just make sure you stop the device. Now by default it is stopped, okay? But in case the devices are in powered on status, you have to power it off first. And then you can right click and simply say delete. And then say okay, and the appliance is deleted. And then you can add whatever you want to add again. So I'll say Versa and select Versa director. scroll down, change the console to telnet and say save. And there you go. Your directory is added. Now we will add the other components. Yes, Ashok, you have a question?
Hi, quick question. Are we going to use version 21 or 22? Because I'm using 22 in my work environment. I would
We're
really
going to use
prefer 22.
21.1. Yeah. We're going to use
Okay.
21.
Because it totally differs from 22. Because 22
Right.
is it possible to do 22?
No, not really. The images which we have received from Versa are on 21 version. And it does not really differ that much. I mean, the fundamentals are still going to be same. It's barely the
Yeah, I
GUI
know.
which might change. Yeah.
Yeah.
Yeah. So that shouldn't be a
Okay.
problem at all.
Okay, that's fine.
All right. So I'm going to click on director, and then I'm going to add the other node now by right clicking, clicking on node, and then search for Versa, and then select the analytics node and post that. Nothing really needs to be changed. So just scroll down and click on save. And I will put the analytics over here. Then right click and click on node again and select the Versa again and select the. Now there is no specific node called controller. Basically, the image or the operating system for the WAN edge and for controller is same. You actually define that in what mode you want to deploy this Flex VNF in. So Flex VNF is kind of an image which can be used for both controller as well as WAN edge. So I'm going to select Versa Flex VNF, and then over here you can see the name is Flex VNF by default. I'm going to change that to Versa controller. And then two CPUs, 4 GB RAM, 6 interfaces by default, and then nothing else. So save that, and you can see the controller coming up. Now, in order to provide the connectivity, we need to provide a southbound connectivity as well as northbound connectivity. If you carefully see on your Windows machine, when I open the command prompt, let me open up a command prompt there. And if I run ipconfig command, you can see the Windows machine would be configured with two interfaces. One is the Ethernet 0, which uses 192.168x.x subnet. And then the other interface is connected to Eve, which uses 10.255 1.x subnet. Now, this interface is bridged to the EVE-NG in the backend in our data center, and you can use that by adding a bridge network. So this time, in order to provide northbound connectivity, you will not click to add the node. No, you will click to add a network. And then the network type must be Cloud One, because this is how the backend is configured. If you use something else in the dropdown, your northbound connectivity will not work. Okay, so you have to use Cloud One. This is just for the lab purpose. Okay, in real life, you probably would be having physical servers and provide connectivity via the physical interfaces. But in lab environment, this is the workaround which we have used. And I will also rename this network as Cloud One. And once we set that, I'm gonna say save. And you can see the cloud interface appears. I'm gonna put it over there. And to provide southbound connectivity, I will add a normal node, which is gonna be switch, Cisco VIOS switch. This is a layer 3 Cisco switch which we will use. I will rename that to DC switch. Okay. And the RAM size, I will decrease it to 512 MB. That's more than enough. It's a very lightweight appliance. And by default, it comes with 8 interfaces, which is fine for us. So save that. And I will put that particular switch over here. Right. And then I'm going to put a box there. So right click, put up a custom shape, square, dashed, and the color as this. Say OK and say save. And then we're gonna there. Yep. So this is gonna be your head-end site. Now to provide the connectivity, you must make sure that your appliances are in powered off state. And the square box before the names of the devices just indicate that the devices are in powered off state. And what I will do is I'm going to simply provide the connectivity. What you need to do is you need to hover your cursor on the appliance. You will see an orange plug sign popping up and then just provide click on that and pull the cable on the other way. Oh, come on. What's happening? There. And then leave it on the other end. Oops, sorry. I'll have to reconnect. Yeah. So I'll show that to you again. I'm simply going to hover my cursor over the director and pull the cable on the other end. And it is going to ask you out of the two interfaces available on the director, which one do you want to use to connect to the cloud? So we're definitely going to use Ethernet 0 for the northbound and say OK, and the connectivity is done. Similarly, you can pull a cable from analytics to the cloud and again select the first interface and pull a cable from controller to the cloud and select the first interface itself and save. Then you provide the southbound connectivity by pulling another cable from director to the DC switch, select the next available interface, then from analytics to the DC switch, and then from the controller to the DC switch. And the controller is going to use the VNI 0/0, which is physically Ethernet 1, but Versa's operating system numbers the interfaces in a different manner, which we're definitely going to talk about. But yeah, for now, just say that this is Ethernet 1, which is written as VNI 0/0. And that's how the controller site networking would be. And like I mentioned, there are two types of subnets which we are using. So we have northbound network, which is 10 dot, sorry, come on, 10.255.1.0/24. And we have southbound network, which is 10.10.10.0/24. And I'll just put this particular tag over here. And then the devices are using .111 as their IP, right? I'm going to put it over here as .111. Then over here, we are using .112 and we are using .113. Yeah. And I will also put up a custom text there as head end. Right? This is our head end. Then we will expand the topology by adding more and more branches there. And once you're good, then I'm simply going to add the director. Start the director. So in order to start your appliance, you simply right click on the appliance and click on the start button. And you can see the color will change and the stop sign will also change to a play button. And to take the console, you simply normally left click on the device and a putty window will pop up, which will show you the process of the appliance booting up. Now this is going to take a couple of minutes. Let's wait for this device to come up.
During the course, would there be any kind of like a point where we would be discussing different models available in Versa? Just comparison of models and stuff like that.
We're going to discuss about the topologies and also implement them. Yes.
No, I'm talking about the hardware and virtual models.
About the data sheets?
Yeah.
Not really, no.
Okay.
Yeah, but I can give you documentation if you'd like. Okay, looks like the director is up now. So what I'm gonna do is, whenever the director is up, you're gonna log in into the director using the credentials administrator, and the password is going to be Versa123, and hit enter. As soon as you log in for the first time in the director, it is going to ask you that do you want to enter the setup? And we say yes, we want to enter the setup. Then it asks you what is the password for your director. That is Versa123 again, all small. And then do you want to set up the host name for the system? We're going to say yes to that. And I'm going to put the host name as director-1. Then it says, do you want to set up the network interfaces configuration? I'll say yes. And then it asks you that what is the interface name that you want to configure? So that is Ethernet 0 for me, first one. Then what is the IP address that you want to configure? So that's 10.255.1.111. Then what is the network mask? So that is 255.255.255.0. What is the gateway? Now gateway is something which is not required, but I will just configure the bridge interfaces gateway that is configured on my IP. I mean that is configured on my second network adapter of the Windows. So I would say 10 to, oh sorry, I'd say yes. And the gateway is 10 to 55, 1.61. Yours might differ. Yours might be 51 probably. And then it says, do you want to configure another interface? I'll say yes. And the second interface is Ethernet 1, whose IP is 10.10.10.1.1.1. And the subnet mask is 255.255.255.0. And it is going to ask you another interface. Well, that's where I'll say no. We only need to configure two interfaces. And after that, it says, do you want to configure northbound interface? That's where I'm going to say yes. And it asks you, what is your northbound interface? I'll say Ethernet 0. Then it says, what is your southbound interface? That is Ethernet 1. Right? And then it says, do you want to configure another southbound interface? I'll say no. And we're good. Then it's simply going to ask you for HA configuration. But since we are not implementing HA, I'll say no to that. No to that. And then it says, would you like a prompt to set the new password at the first time UI login? I will say yes. And once it is done,
Abhijit Gopi here.
mm-hmm.
Are we having some more, like, how long still this session is still left? Because I need to take care some personal stuff.
Yeah, we'll be here for maybe another 10 minutes.
Okay, maybe I'll catch up in the recording.
No problem yet. The sessions are getting recorded, so that's fine.
Thank you.
Thank you. All right. So once we do that configuration, the director will kind of reboot. Meanwhile, the director is rebooting. I'm going to start my analytics and I'm going to start my controller as well as I'm going to start my DC switch. And I will take the console of my analytics node and I'm going to take the console of my controller node and let them boot up. The analytics and controller node are lightweight nodes. They won't take as much time as the director takes to boot up. So let's wait for these guys to boot up. And there, you can see the analytics node is up. Now apart from just the director, every other node, including the analytics, the controller, the WAN edges, everyone could be logged in by using the username called Versa and the password as Versa123. It is just the director which requires you to log in using administrator as the username. Okay. So I've logged in into the analytics using the Versa and Versa123 as my credentials. And there won't be any setup script which will run just like director. So you'll have to use Linux commands over here to configure the basic IP addressing. Now, in order to configure the IP address temporarily on the Ethernet 0 and Ethernet 1, we can use the Linux's ifconfig utility. So I would say sudo ifconfig Ethernet 0. The IP address has to be 10.255.1.112/24 and the status has to be up. And then it asks you for the password because you're using sudo and done. And then I would say sudo ifconfig Ethernet 1 10.10.10.112/24 up
Yeah, Abhijit, I
and done.
missed that part. Can you please repeat it? What's the
I'm
analytics?
saying that in order to configure the IP address temporarily onto the analytics and onto the controller, we will use the ifconfig utility of Linux because all the operating systems of Versa are based on the Linux kernel. Sounds
Running
good?
on Ubuntu, right?
Yeah, you can say that. Ubuntu, I mean Linux kernel, Ubuntu also uses Linux kernel, right? So,
Okay.
and then, but these are barely temporary IP address, which means if I use the command called ifconfig pipeless, it is going to show you that the IP address on the Ethernet 0 is 10.255.1.112 and Ethernet 1 it is 10.10.10.11. But if I reboot my device, then the IPs will go away. So I need to hard code these address settings into a file which the Linux machines use to configure IP addresses on its interface. So that file can be modified by using a nano tool. Nano is a text editor in Ubuntu. So I'm going to sudo nano /etc/network/interfaces. This is the file which we will be modifying. I hit enter into that file. So there the primary network interface, and this is where we need to make modification. So it tells you that by default the Ethernet 0 interface is set to receive IP address via DHCP. But instead of DHCP, we will change it to static. And then in that I will say the address has to be 10.255.1.111. The net mask has to be, oh sorry, it is analytics, right? So 112. The net mask has to be 255.255.255.0 and the gateway can be 10.255.1.61. Then we have another interface. So auto Ethernet 1, interface Ethernet 1, inet static, and then the address has to be 10.255.1.11. Oh, sorry, 10.10.10.112 and the net mask 255.255.255.0. And that's all. Once you are done modifying this file, you save the file by using a keyword combination called Control X, and then it asks you that do you want to save the modified buffer? I will hit Y there, and then it asks you that do you want to keep the file name as it is, and hit enter there. So Control X, Y, and enter. It is written in the lab activity guide. And once you're done, then the IP address configuration on the analytics is complete. Now, post that, we will move on to the IP address configuration on the controller. Okay, and we will follow the same process that we did on the analytics. It is just that the controller on the controller, you only need to configure Ethernet 0. You are not required to configure the Ethernet 1 because that is going to be done from the director's GUI. So only configure one interface, not two, unlike analytics. So I'm going to log in again using Versa and Versa123. And then I'll say sudo ifconfig Ethernet 0 10.255.1.113/24 up. And the password Versa123. Then sudo nano /etc/network/interfaces. And there I'm going to configure Ethernet 0 with static command where the address is gonna be 10 to 55 1.11 3, and the net mask 255.255.255.0, and the gateway 10 10 10, sorry, 10 to 55 1.61, and control X Y enter, and you're done. And if I click on ifconfig command, it shows me that the Ethernet 0 is configured with 10 to 55 1. And then I can also say ping 10 to 55 1.111. And if the reachability comes up, then you're good. There you go. And then if I try to ping 10 to 55 1.112, that reachability is also up, which means this communication between the controllers over the northbound network has been established. I can circle back to analytics and try the southbound communication with the director, and that is also working fine. So the IP addressing is fine. And just because these devices are connected to the out of band management also, so if I now open up my command prompt, right, and then try to ping the director from here, 10 to 55 1.111, you can see the reachability of the director comes up. And because the reachability is up, I can open up a new tab in my Firefox and then say https:// 10 to 55 1.111. When I hit the northbound IP address of the director in my browser, let's see if the director is up. I guess, yeah, you see the setup is completed. So press enter to continue and you're done. And you can see that the web page is loaded. It says potential security risk. So go to advanced and then go to accept the risk and continue. And you should see the Versa director login page. It's loading that.
For the analytics also cannot we configure the southbound IP address from director?
No, we did. Oh, you cannot configure the southbound IP address on the analytics. No, you cannot. You have to do it in the analytics itself.
Okay. Because once it's reachable, I thought, from director over the northbound, it becomes reachable, and from there we might be able.
No, that's not how. The process for adding the analytics and the control is different on the director. And then I will try to log in into the director by using administrator and Versa 123. Now remember, it's gonna ask you to change the password. So when I say Versa 123 as my password, just click on login. And for the first time when you log in, it should ask you to change the password. It will take a minute or so.
So comparing to our traditional devices, we can still have loopbacks configured on these boxes, right? Or it's only this IP addresses
Of
we have
course,
to use.
yes. You can. And there it says enter your details to change your password. So I'm gonna put the old password, which is Versa 123, and the new password is Versa @123 with V capital. Okay. When I put it, I'm gonna say change. Perfect. And then once it's done, I should be able to log in into the director using the new password. Click on login and it should take me in. There. And once we log in for the first time, it's going to give you two warnings on the right lower corner. It says certificate expire. Since we're in lab environment, ignore that. And then it says license expire. And you have the Versa Director license, which is activated for 15 days. Okay. But since the training will span for more than 15 days, What you are expected to do is every time you are done practicing the lab, you are supposed to power off the director by right clicking and then stop, or rather stop the entire lab by going to the menu and then clicking on more actions and stop all modes. When you do that, just don't let 24 hours be crossed while the director is up. Because if you keep the director up for continuous 15 days, then only the license will expire. If you power it off before it crosses 15 days, then it will still cross like every single day as it goes. So before it crosses, the best practice that I suggest is before it crosses 24 hours, just power it off and then maybe power it on again. So this will reset the timer, and then you can use the accelerator as long as you want. It will never expire in that case, right? So that is what the take care of director that you can do whenever you access it. And then yeah, pretty good. So that is something which we wanted to talk about. That how you can do the basic configuration onto the topology, and how does the GUI really looks like. Well, how does the GUI works? What all are the menu items? How do we add the analytics and the controller inside the director for the registration and all? That is gonna be the agenda for tomorrow's class. But yeah, for today, we wanted to talk about the fundamentals of SD-WAN. We wanted to understand the components of Versa's SD-WAN, and then we were able to create the head-end topology and also do the basic configurations on it. Any questions? Please raise your hands. Awesome.